Okay, ladies and gentlemen, so here we have a system of equations. Here are two equations, right? We know that if I graph this equation, I'm going to get a straight line because I see an x and a y. If I graph this equation, I'm going to get a straight line. I see an x and I see a y. And the whole point of this, no pun intended, is that when we graph these two lines, there's going to be a point of intersection, right? Remember that each point has two values. Each point has an x value and a y value, right? So when we're done with this, when we use the substitution method, right, we should get a point that looks like this, x, y. And what we're asked here is, what is the y value? So this value, not this guy, this guy. And this is where most of you got this wrong, because I kept getting emails about, I'm getting this for x. Great, that's not what I asked for. What I asked for is the value of y. So make sure you're always careful when reading the questions. So here we go. In order to use the substitution method, we want one of our equations, at least one, to be either solved for x or solved for y. In this particular case, we have this equation here, which is already solved for y. So we know that y is negative 6x minus 15, right? So we know that on our next equation, wherever we see a y, which is right here, instead of that y, we can write negative 6x minus 15. So here we go. We have negative 5x plus 2y, but instead of y, I'm going to open parentheses, right? Equals 4. So essentially what I just did is I wrote down this top equation, right? Except for the parentheses part. So instead of parentheses, I should have a y. But I wrote parentheses because I know that wherever I see a y, I could write negative 6x minus 15. And you might be asking yourself, well, why write all that if y seems so much simpler? Well, when you solve equations, you don't want to have two variables to solve for. You want to have just one. And if I write negative 6x minus 15 right here, notice that now the only variable I have is x. See, I see x right there, I see x right here. So now I can actually solve this equation and I'm going to get the value of x, which is going to be this value, right? And I'm still not going to be done. So let's solve for x. So again, we're going to use the order of operations to solve because it's an equation, right? So let me write the order of operations. Okay, so I see parentheses here. And when you see parentheses, you're asking yourself, is there an operation here? Yeah, there's subtraction. Can I subtract 15 from negative 6x? No, because they are unlike terms. So parentheses, gone. Let's try that again. Any exponents? No, I don't see any exponents, so that's also gone. Multiplication, division from left to right. Well, I do see multiplication. This is 2 times negative 6x and also 2 times negative 15. So I'm going to write that down right now. So there we go. We have 2 times negative 6x and 2 times negative 15. But I still haven't multiplied. So when I multiply 2 times negative 6x, I get negative 12x. And when I multiply positive 2 times negative 15, I get negative 30. Equals 4. And then on the left side right here, I got to bring that negative 5x down. Now I go back to my order of operations. Any more multiplication or division? Well, let's check. Nope. So we're done with multiplication and division. And now we have addition, subtraction. Well, let's see. That's negative 5x minus 12x. Yeah, we got subtraction right here. This is where last week I messed up, and Ariane was kind enough to call me out on it. And I even gave you guys kind of like a speech of, hey, don't mess up with your integers, and I messed up with my integers. So here we go. Negative 5x minus 12x. Well, let's just think as negative 5 minus 12. Negative 5 minus 12 is going to be negative 17. This time, I'm pretty sure I'm right, guys. So this is going to be negative 17x minus 30 equals 4. There's more subtraction here, but I really can't subtract 30 from negative 17x because they are unlike terms. So I am done with my order of operations. And since I am done with my order of operations, now I get to isolate the variable, which would be negative 17x. So I want to create a zero pair right here. I'm going to add 30 to each side. And I'm going to get a brand new equation, which is, let's try this again. Okay. I'm going to get negative 17x equals 34. And this works out. I can already see this is working out because 17 and 34 are very friendly numbers. Now I'm going to divide by the coefficient, which is negative 17. So each side gets divided by negative 17. And I know that this becomes 1x because negative 17 over negative 17 is a giant 1, right? So this becomes 1x, or simply just x. Let's try that again. Equals, well, this is a positive divided by a negative, so I know I'm going to get a negative. 34 divided by 17 is 2. So x equals negative 2. And a lot of people were punching in on Edulastic. They were typing in negative 2. And then you were perplexed. You were confused because you were getting it wrong. And you went through your entire work and you were like, hey, I'm right. You're right. X equals negative 2. That's not what I asked you for. I asked you for the value of y. So now, to get the value of y, I need to substitute this negative 2 into one of these two, let's try this again, to one of these two equations right here. And I'm going to go with this one because this one already says y equals negative 6x minus 15. So wherever I see an x, I'm going to put that negative 2. Here we go. So I have y equals negative 6 times x, but instead of x, I'm going to put parentheses, minus 15. And I'm going to take this negative 2 right here and put it right here, because that's the value of x, negative 2. Now I have negative 6 times negative 2, and negative times a negative is a positive. So I'm going to get y equals 12 minus 15. Y equals, well, 12 minus 15 is negative 3. And this, kiddos, is what you were looking for. Okay, I hope this helped. I'll see you guys on the next video.